In section 3.2, we're learning about the graphs of functions. Some of the things we're going to do here are determine whether or not the graph represents a function, and we have done this in previous sections. We're going to analyze graphs and determine the domain and range, the local max and min. We're going to talk about the inflection points, the intervals of where the function is increasing and decreasing, and also the intervals where the function's concave up and concave down. So to do this, we're actually going to look at just one graph for the most part, and this is the graph that we're going to be looking at. And we're going to find all of those things for this graph. So first, let's just go through and talk about some of the things we know. We know it's a function, and we know it's a function because it passes the vertical line test. So let's think of the vertical line test as here we have a vertical line. Now, as this line passes through each part, you notice that it only intersects the green function at one point every time. If it ever intersects it at more than one point, then we know that this would not be a function. So here we have it passing the vertical line test. And so we do have a function here. So that's the first thing we need to know. Okay. Now let's talk about the domain of this function. You notice here that it looks like it's going to go to infinity here because this part of the graph, it's going to go to negative infinity for the x, and then positive infinity here. So we would say that the domain of this function would be from negative infinity to positive infinity. And we're always using parentheses with the infinity. Okay, now we need to talk about the range. Okay, so the range is the maximum and minimum y value on the graph. So if you look at how low does it go, then you know this arrow is going to continue here. So it's going to negative infinity in this direction. And then how high does it go up? Well, it looks like the height is right about here, which that is at 7. So y value of 7. So it looks like our range is going to be from negative infinity up to positive 7, and it includes that 7. Okay, so we have the domain and the range there. Now that we have those, and that's some of the things that we have reviewed, that we've done previously, we're going to go ahead and start talking about our local max and our local minimum values. So these local max and local min points are not necessarily the highest and the lowest points on the graph that we were looking for when we were talking about the range. Instead, what they are is they are the highest and lowest points within a neighborhood. So it's basically anytime you have peaks or valleys. So let's go through and look for any peaks first. So it looks like I have a peak here, and it looks like we have a peak here. All of the peaks are called our local max points. So and we can look and say approximately where those occur. And we're only referring to the x values in this case. So they happen at approximately where x is equal to -5. And then there's another at approximately x equal to 2. Okay, so that's our local max values. Now let's take a look and see if we see any. Let's see if we see any valleys. So our valleys happen here at these 2 points. Those valleys are going to be our local minimums. And those occur at approximately x equal to -1.5 and where x is at about 6. Now those are important because they're going to help us with something called our inflection points in a little bit. So take a look back. We have our local max and our local mins. Those are the peaks and the valleys of the graphs. Now we're going to move on and talk about the increasing intervals and the decreasing intervals. And let's just write a little bit down for this. So of course this is just the intervals for which the function is increasing, and that's when it rises from left to right. Okay, so let's go through and identify where we are rising from left to right on our graph. And I'm going to do this in blue, just like I have here. So it looks like we are rising from left to right at this part of the graph. And then again, we're rising left to right in this part of the graph. And then again at this part of the graph. So we've identified 3 different areas when we're rising left to right, and those are increasing intervals. And so if we look at the x values associated with those, then this is where x is at, it's going from negative infinity here to, this is where x is at negative 5. Okay, so our first increasing interval is here. All right, so from negative infinity up to negative 5. And we're using parentheses, and we're always using our x values on this. Anytime you're talking about intervals, you use the parentheses and you don't use the brackets. It looks like the next one is from here, which that's where our x value is approximately negative, the graph's a little off, so about negative 1.5 up to where we have an x value of 2, so here. And then the last one would be from here to here, and it looks like we have x values here of 6 up to 8. So from 6 to 8. Okay, and those are our intervals for which the function is increasing. Now let's go through and see if we can find our intervals decreasing. So I'm going over those in red. So our intervals of decreasing are here. That's 1. And then here's the second one. And the numbers that I've put on here for the increasing are actually going to help us with this one. So it looks like we are decreasing from negative 5 up to negative 1.5. And then we're also decreasing again from 2 up to 6. And we should add, just like we did for the increasing interval, is that the decreasing interval is actually where it's falling from left to right. And then the last one we have is our constant interval. And our constant interval is just where we're constant. So that happens here. And our constant interval is just going to be from where x is 8 to positive infinity. Okay, we're going to move on from here, and we're going to talk about points of inflection. We're also going to talk a little bit about concavity here. So we'll start out with the points of inflection. On the same graph. The points of inflection are the points where the curve changes concavity. So then we need to talk about concavity. Concavity is just a description of how the curve bends. So we're either concave up or we're concave down. So let's talk about concavity for a minute. If I can connect 2 points on a curve here, like this, and that falls below the curve, then we call this actually sort of the opposite of what you think you might say here. This is going to be concave down. All right, and then if I can connect 2 points here in red on a curve, and the curve falls below, then we call that concave up. Okay, so take a minute to look at that and see if you can find other points where this function is concave up or concave down. You should be able to find 2 more instances here. Okay, so now that we understand the concave up and the concave down, let's go ahead and talk about our points of inflection a little more. I'm going to erase this. And take off a little more of my graph than I wanted to. Okay, so now let's talk about the points of inflection. It's point where the curve changes, concavity. So these points are we're going to identify them as sort of the midpoints of those local max and min points. So let's go through and maybe identify what they may be. So here, from here to here, we are concave down. And then we have this point of inflection somewhere around here. And then back here, so we have another point of inflection. And then over here somewhere we have another point of inflection, and then this last point of inflection. So we've identified the 4 points of inflection that we're going to be dealing with here. So we're going to call this one A for now, this one B, C, and D. Well, to find those points of inflection, what we need to do is really go through and mark what these local max and min values are. Let me actually do that in a different color. Okay, so the x value here, this first one was at approximately -5. And I think we identify this one as -1.5, even though it looks maybe a little different. We're going with the -1.5. This value here was +2, and this local min here was at 6, and then of course the x value here is at 8. So that one's a little easier to see. The others, A, B, and C, we might have to calculate, whereas D, we know it's a, you can tell that X is at approximately 8. So when we go through and we calculate those points of inflection, we just use our midpoint formula. So let's go through and calculate A first. A is going to be at the average of the -5. It's right between the -5 and the -1.5. So to find A, you see that it falls between the -5 and the -1.5. We just use our midpoint formula. Add the 2 and divide by 2. And when we do that, we're going to get -3.25. Okay, so one of the points of inflection is going to be where x is equal to approximately -3.25. And then when we're looking for B, again, B is going to be the average of the -1.5 and then the +2, so -1.5 plus the 2 divided by 2. And for that one, we're going to get 0.25, or x is 0.25. And then for point C, this one is the average of the 2 and the 6. And so we get at approximately 4 on that one. And D, we said that one is clear. That's where the x value is at 8. Approximately 8 there. There's nothing to average for D. So here we have the points of inflection. Now we have the points of inflection, we can actually go through and identify the intervals of concavity. Okay, so for concavity, we know that it describes how the curve bends. And we have concave up and we have concave down. And this is really, I think, the most confusing concept, just because you sort of tend to think that concave up is concave down and vice versa. So let's just go through and look at some intervals where we are concave up. Okay, so we are going to be concave up where basically we have a local min. So we have a period of concave up from somewhere in here to about halfway up this next curve. So that would be a concave up area there. And then we have another one that happens somewhere in here. Okay, so we're going to identify those intervals. Now, the reason we went through and found those points of inflection first is because we're going to use those points of inflection to talk about these intervals. We're going to need them. Okay, so we identified A, B, C, and D on the last part, and now we're going to use that to talk about our intervals of concave up and concave down. So now that we have these intervals of concavity up marked, let's go through and say, well, we know it was from our, we have the first concave up from A, from the next value right at A over to B. And so that's going to be from negative 3.25, according to our calculations on the previous slide, all the way up to where X is 0.25. And then the second one happens where X starts out at approximately 4 and moves on to 8. So those are areas of concavity up. Now let's move through and talk about concave down. And that is going to take place where we have, where I have it marked in red. And that's going to be from here all the way to A, and then from B to C, and that's all we have. All right, so let's go from those. We have from negative infinity all the way up to A, and A had a value of negative 3.25. And then the second one would be from B to C, and that is from 0.25 all the way up to 4. Okay, and so now we have our concave up and concave down. Keep in mind that you need to use points of inflection to find these. These are, you note these intervals using the points of inflection, which is why we cover the points of inflection first. Now let's look at an example where we're going to use our calculator. We have this function here, and what I want you to do is to identify all of the local max and the mins for this function. Now the difference between this one and the ones that we've done previously is that you get to use your calculator, and so your calculator gets to do all of the calculating instead of you. You're not counting those. All right, so I already have this function in to my calculator. And now that I have it in, I'm going to look at a graph, just do a zoom 6 standard viewing window. And you'll notice that we don't get the best graph here. And it's compared to the previous graph, it's not as dramatic. So you see concave up, concave down, intervals increasing and decreasing, but it's certainly not as dramatic as the others. So you're left thinking, do I have a local max and a local min, or is that not a local max and a local min? The answer is yes, you do. You have one local max, you have one local min on this cubic function. So we're going to change this graph a little bit. I'm going from negative 10 to positive 10 right now in my domain, and I don't need that much. So I'm going to change that and go from negative 4 to positive 4. And then my max, let's change that to, or let's change my min to negative 5 and down to, and up to positive 5. And let's look at the graph for that and see if we get a better idea. We do, but you notice that maybe I went down too far and not up far enough, so we can take a little off the bottom there by changing my min. Let's change that to negative 2, and let's go up a little further, maybe to 7. And let's look at a graph here. Okay, now we have a better graph. So you can sort of identify the local max and the min there. So we're going to use our calculator to help us do that. Let's just look at what we have for a minute. Okay, so if this is our graph here, we've got to go and look for our local max and our local min. So it looks like about right here might be a local max. And then it looks like right here might be a min. Okay, and what we're going to use on our calculator is those functions, the max and the min functions, to help us find. And it's going to ask us, so for instance, when we're finding for the local max, it's going to ask you for a right and a left side. So what we're going to do is try to trap this. We're going to trap it by noting a piece on this side and a piece on this side, and then our calculator is going to ask us to guess. So this is going to be the left, this is going to be the right. Now when we do the min, it's going to sort of be the opposite. We're going to do, this is the left, and then over here is the right, and then it'll ask us to guess, and it'll figure out what those values are. So moving back to our calculator here, I'm going second calc. I want to find, let's find the min first, which is number 3. And so I'm going to move over, and it's asking for a left boundary like I said it would. So let's press enter there, and now let's move clearly to the right side of that minimum. There, it's good, and it's asking us to guess. And it looks like we're having a local min at approximately 1.096. So we can come over here and say, okay, and again, we only need to worry about the x values. And then the local max, let's go through and find that now. Second calc, I'm going for the max this time, which is number 4. Okay, so I need to move to the left side of that maximum here, and then move to the right side of that maximum here, and press enter. And it says the maximum there is at approximately 0.304. So here we go. All right, and then we have the local max and the local min for that. So that's how you would do it if you're not looking at a graph like we have here. Okay, that's how you can use your calculator, a comparison of those. And of course, you could go through, find your points of inflection, your intervals of increasing and decreasing, and your intervals for concavity up and concavity down as well. That's all I have for section 3.2.